Okay, ladies and gentlemen of algebra, you're talking about Unit 9, Notes 1, talking about inverse variation. So what you need to be able to do once you're done is write and graph inverse variation equations. So let's jump right in. So the number of revolutions of the pedals made while riding a bicycle at a constant speed varies inversely as the gear ratio of the bicycle. In other words, as the gear ratio decreases, the revolutions per minute increases. So as the gear ratio goes down, that means you're pedaling a bike faster to go the same speed. This is why shifting to a lower gear allows you to pedal with less difficulty when riding up a hill. I think that's supposed to be riding. So y varies inversely as x if there is some non-zero constant k such that xy equals k. Basically, two numbers are always going to multiply to the same thing. So here, the time t it takes to travel a certain distance varies inversely at the rate in which you travel. Basically, if you go faster, you will travel faster, and it will take you less time. Whereas if you go slower, it will take you longer. So the equation RT is rate times time equals 250 for 250 miles. So complete the table and draw a graph of this relation. So basically, R times T has to equal 250. Okay, that's kind of the punchline here. Is R times T has got to equal 250. So basically, I'm taking 250 divided by everything in R, and that's going to give me T. So 250 divided by 5 is going to be 50. 250 divided by 10 is going to be 25. 250 divided by 15 is going to be 16. Is going to be 16 and 2/3 or 0.66 repeating. So 16.66. Okay, 250 divided by 20 is going to be 13 and a half. 250 divided by 25 is going to be 10. 250 divided by 30 is going to be 8.33. 250 divided by 35 is going to be 7.14. 250 divided by 40 is going to be 6.25. 250 divided by 50 is going to be 5. 250 divided by 45 is going to be 5.55. Sorry, that's a 5.55. So when I graph this thing, that's what I'm plotting. Okay, I'm plotting these points. So at 5, I'm at 50. At 10, I'm at 25. At 15, I'm at 13.5. 20, I'm at 10. So you start to get kind of an idea what this is going to look like. But this is going to bottom out there. So that's kind of what that graph is going to look like. So here, graph the inverse variation in which y varies inversely as x. So when y equals 15, x equals 6. So that's going to be the very first thing I put into this table. All right, so I'm going to take y is 15 when x equals 6. So x equals 6, y equals 15. Well, when I multiply that, 15 times 6 is 90. So basically, all of these got to be 90. So you can play around with different combinations that get you 90. So I can say 9 and 10. I can say 10 and 9. I can say, 30 and 3, 3 and 30, 30 and 3, anything like that. I can also mess around with negative numbers. So I can say, hey, negative 9 and negative 10 both give me 90. Negative 10, negative 9 give me 90. And just to get another one, negative 5 and 18, negative 18, and negative 18, negative 5 both equal 90. So all those are going to work. So plotting that point is going to look like this. So if I kind of shrink this up a little bit. So if I look around here, so I got 6, 15, and then 15, 6. So the big idea here is this. So I'm going to let each box be like 5. So 5, 10, 15. And so this will be 5, 10, 15 going across. So if I'm at 615, so I'm up at 615, I'm there. So then I flip that around, that's also going to be 15, 6. So I'll be there. So it's going to look kind of like this. So then flip it around and look at the negative. It's also that same idea. So it's going to be at negative 5, I'm at negative 18. So that's going to be right there. And then at negative 18, I'm going to be at 5, which is going to be right there. So it's going to follow along. So that's what that graph is going to look like. It's never going to touch the vertices, but it's going to be approaching them in both directions. So if I look kind of like that same idea here, y equals 12, x equals 4. So my very first thing, y equals 12 when x equals 4, well, that's going to equal 48. So now I start thinking about every possible combination that can give me 48. 6 and 8, 8 and 6, 3 and 16, 16 and 3, and I can keep going, but also realize that all these negatives also work. 6, negative 6, negative 8, negative 8, negative 6, negative 3, negative 16, negative 16, negative 3. All those things work. I don't know why I drew that or that. So all of these are going to give me 48 all the way across the board. And there's more. You can keep going with that. So the punchline is that when you do this, when you sketch this graph, that's going to be what the case is. So if I look and I let each one, say I let each one just be 4 this time. So that's 4, 8, 12, 16, 20. So that's going to be 4, 8, 12, 16, 20. So start plotting the points. So if I start 4, 12, 4, 12, 12 and 4 match that. So that's going to be right there. And, 48 is 16 times 3. So if I come over here 16, 3 is going to be right about there. Same thing, 3, 16 is going to be right about there. So 8 times 6 is going to give me right there and right there. So you start to get an idea of what this graph is going to look like. So then flip it around, it's going to be kind of a mirror effect down here too. So I get, negative 4, negative 12, and then negative 12, negative 4, negative 8, negative 6, negative 6, negative 8. So it kind of gets that same idea going there. So here's something you should probably highlight and put somewhere in your notes, is this situation right here. X's over x's equal y over y. So first x over second x equals second y over first y. So just to kind of get an idea what I'm talking about, first x over second x equals second y over first y. So y varies inversely as x, so y equals 4 when x equals 7. Find x when y equals 14. Okay, so my very first y was 4 and my very first x was 7. So figure out what x is when y equals 14. So this is kind of my setup. 7 times 4 is 28 equals 14x, using cross products now. So divide by 14, x equals 2. There's my answer. So same kind of idea here for number 5. So y varies inversely as x, so in y equals 4 when x equals negative 8. So first x, or first y, first x, second y is what I'm looking for when x equals negative 4. So go diagonal, so negative 32 equals negative 4y. And little solving should be 8 equals y. There's my answer. So now, earth science, as the temperature increases, the water level of the water decreases. So when the temperature is 90 degrees, the water level is 11 feet. So 90 and 11. If the temperature was 110, what would be the water of the river? Write an equation to show this. So If x is my temperature, so that'd be x1, and that would be x2, y1, y2. So remember, x over x, first x over second x equals second y over first y. So the first y was 11, and we're looking for this other y. So 90 over 110 equals y over 11. So now depending on how you do it, if you use cross products, that's 110y equals 990. Divide by 110. Y is going to equal 9. So when the temperature is 110 degrees, the water level is going to be 9. So two people are balanced on a seesaw. The distance from the center of the seesaw is inversely proportional, big word, keyword. If a 118-pound person sits 1.8 meters from the center of the seesaw, how far should a 125-pound person sit from the center to balance the seesaw? So once again, 118 and 125, x1 will be my 118, x2 will be 125, y1 will be 1.8, y2 is what I'm looking for. So I'm going to take 118 over 125, and that's going to be equal to 1.8 over y. So 118 times y gives me 118y. 125 times 1.8 is going to give me 225. So a little division, and y is going to be equal to 1.91. So about 1.9 meters away. Okay, that's all I got. Come talk to me with questions.